I'm going to be going over the technique of how to solve limits at infinity with square roots, these types of problems. You can expect these types of questions on your Calculus 1 exam. This is very typical. Okay, so this is how it looks like. You might have seen this before. Limit as x approaches either positive infinity or negative infinity, and it looks like a rational function, but there's a square root or something like that in the function, okay? So in this particular case, limit as x approaches negative infinity, square root of 1 plus 4x to the 6 over 2 plus x cubed, okay? So if you're given this on the final exam, and by that point you might have learned L'Hopital's rule, you might be tempted to just use L'Hopital's rule right away, because technically, this is an infinity over infinity, so you could, in theory, use L'Hopital's rule. But in this particular problem, I would not even bother attempting L'Hopital's rule. And I actually showed a few steps here. Okay, so it's infinity over infinity, so we can differentiate the top, which is this guy. We need the chain rule. I'm not going to go over all that. And then we differentiate the bottom, that's 3x squared, okay? If we simplify, that's this right here. I'm not going to go over that in the interest of time, but it's still infinity over infinity, right? So we use L'Hopital's rule again. Differentiate the top, you get 12x squared. Differentiate the bottom, you get that mess over here. You start simplifying, you get this over here. It's infinity over infinity again. You could differentiate again, do L'Hopital's rule again, simplify, and then it's endless. It's an endless loop. You're not going to get anywhere with this. Okay? So we have to go back. If you already learned L'Hopital's rule, you have to go back to when you first learned about limits. What was the technique to solve these types of problems? How do we solve these horizontal asymptote problems? This limit at infinity is basically asking, is there a horizontal asymptote? If there is, what is it? What is it going to approach? Okay, this is how we do it. Okay, remember we factor the biggest degrees. Does that sound kind of familiar? So the biggest degree on top, well, it's inside the square root. That's x to the 6. So we factor that out right here. And we factor out x cubed on the bottom. That's the biggest degree on the bottom. Okay, so we get that right here. And that you can use properties of radicals to split these two up like this. Okay, now this is the conceptual part of simplifying this. So square root of x to the 6, we can rewrite as absolute value of x cubed, which is plus or minus x cubed, okay? And this is what most students think. Square root of x to the 6, that's plus or minus x cubed, but you can rewrite it as absolute value of x cubed, okay? So is it plus x cubed or is it minus x cubed? Which one is it, the positive or the negative? So this is where this representation, this absolute value of x cubed is helpful. Let's recall what this is. Let's write it as a piecewise function. Absolute value of x cubed is x cubed when x is greater than 0. We can even say greater than or equal to 0, okay? And it is negative x cubed for x is less than 0, okay? So therefore, if we understand this square root of x to the 6 as this piecewise function representation, as x approaches negative infinity, which branch are we on? We're on this bottom branch, right? Because x is negative. We're going to be following the negative x cubed curve. So that's why we choose minus x cubed. This is how we understand. And let's look at the graphs, actually. So here I plot square root of x to the 6. Looks like this, okay? And here I've overlaid on top y equals x cubed. So as x approaches infinity, you can see these two behaviors don't match. So it's not following positive x cubed as x approaches negative infinity. Okay, so instead, if I plot y equals negative x cubed, you can see it's matching well. So that's why this is from a graphical perspective. As x approaches minus infinity, square root of x to the 6 approaches minus x cubed. It follows minus x cubed. Okay, follows the same curve. So that's why, let's go back to the problem now. We replace this square root of x to the 6 with a simple minus x cubed right here, okay? And then let's do some simplification. These x cubes would cancel, and you're left with this here, right? Now let's take the limit. Now, recall, we like this type of representation when we take limits to infinity because 1 over x to the 6, as x keeps getting bigger, even though it's going bigger in the negative direction, so more and more negative, this is going to go to 0, okay? And same with this. 2 over x cubed would approach 0 as x approaches negative infinity. So what are we left with? We're left with minus square root of 4 over 1, which is negative 2. And we look at the graph of the original function, which I plot over here. Yeah, it does approach negative 2. We confirmed that. Okay, so that's the technique. It's not hard. You just got to realize this trick over here. You factor the biggest degree, and then you got to be careful when you have these square roots over here. You got to have the right sign. Okay, so you could technically think of it as, since we're approaching negative infinity, these guys are going to be negative. Okay, that is possibly okay. I'm pretty sure it's okay. However, people tend to get confused and think of it like this. This is not the right way to think about it. It's not correct to think that since x approaches negative infinity, the final answer must be negative. Okay? It happened to be the case for this problem over here, but that's not always the case. For example, as x approaches minus infinity of negative 2x over square of 4x squared plus 11, we look at the graph. I graphed it over here. As we approach minus infinity, it's going to approach positive 1, okay? But if we simply think that the final answer must be negative, that's not right if we do the same steps as before. So let me go over that. So the top, we don't need to factor out anything. There's only one term. The bottom, inside the square root, we factor out x squared, and then we can separate that square of x squared, properties of radicals. And this, here's where the problem occurs, since if you think of it as x approaches minus infinity, the final answer must be negative, then we just keep this as positive. And then you simplify and take the limit, you get minus 1, which is not the case, okay? If you do it the other shortcut way, that's why I don't recommend people think of it like that. It's risky because they might get confused with this slide over here. But if we shortcut it and think of it as, since we're approaching negative infinity, the square root of x squared must be negative, then that's correct because these two negatives over here make a positive. So we would get a final answer of 1, and that matches the graph, which we expected, which we would hope, I should say. All right, so to recap one more time, don't use L'Hopital's rule for these types of problems. You're going to, by the end of the test, you're still not going to be done. You'll be taking derivatives, okay? Instead, we factored the biggest degrees, and we have to be careful when we're square rooting the powers over here. You have to choose the right sign. Okay, that's it for this video. Hopefully it was helpful. Please give it a like if it was, and hopefully I'll see you in another video as well. Bye.